Hello everyone. My name is Vidish Kumar Kasanagottu. I am from CSC Cybersecurity B section. Today my topic is Pascal's triangle using Python. Pascal's triangle is a diagrammatic representation of a sequential theory from combinatorics topic. In mathematics, it is explained by using binomial expansion theory. In Python, it can be represented or developed by a code using a math module. We can also define Pascal's triangle as a two-dimensional number pyramid where numbers can be arranged in a form of triangle. History of Pascal's triangle. Pascal's triangle is named after a French mathematician named Blaise Pascal. He did not invent the theory, but history has gifted the credit of discovery to him. It is a Chinese originated concept. It can also be considered as n ordered matrix with empty spaces and numbers as its elements. It is a sequence theory in number system like Fibonacci series. Use of Python to build Pascal's triangle. Python language features include interactive and general purpose usage. With this property, we can make a Pascal triangle in Python. Elements of Pascal triangle are binomial coefficients of expansion a plus b to the power of n. It is comparatively convenient and also easy to use Python for building a Pascal triangle of desired extent. Now coming to the algorithm, can use math library and also iterate iterative statements like while loop or for loop for this program. It is the main important concept for this program. Nested loops in Python. A nested loop is a loop inside a loop. It is house is a loop and the room inside the house is another loop. The inner loop will be executed one time for each iteration of outer loop. A nested loop is a loop inside the body of the outer loop. So after executing the outer loop, the inner loop will be executed until the inner loop becomes false. The outer loop again will not be executed. The inner loop or outer loop can be any type such as while loop or for loop. So we can also use both type of loops. The outer loop contains more than one loop and there is also no limitation in Python for chaining of loops. The use of mathematics in Python. There is a formula known as combination formula which is used in solving the problems related to combinations or selections, that is NCR equals to n factorial by n minus r factorial into r factorial. It is pronounced as r number of selections taking from n number of choices. Binomial is the application of the previous formula. Binomial expansion is simple to verify, that is a plus b to the power of n equals to nc naught into a to the power of n into b to the power of 0 plus so on ncn a to the power of 0 into b to the power of n. Here the coefficients of the binomial products are the elements in the Pascal triangle, which is explained further. In this figure, it explains the Pascal triangle. A plus b to the power of 0 equals to 1. A plus b to the power of 1 equals to a plus b. Like that, if we increase the degree, the number of elements also increased. It is the code snippet for Pascal's triangle. So now I am going to explain my code snippet of the Pascal's triangle. First of all, let me introduce the formula called a plus b to the power of n, which basically means nc naught a to the power of n into b to the power of 0 plus nc1 a to the power of n minus 1 into b to the power of 1 plus so on, and at the end we will get ncn a to the power of 0 into b to the power of n. Here nc0, nc1 up to ncn, these are called binomial coefficients with which we can form a Pascal's triangle. Now if we take like a plus b whole square, it is written as 2c naught and a to the power of 2 into b to the power of 0 plus 2c1 a to the power of 1 into b to the power of 1 plus 2c2 a to the power of 0 into b to the power of 2. It is written as a square plus 2ab plus b square. So these three terms such as 2c0, 2c1 and 2c2, 1, 2, 1. So these are the elements of Pascal's triangle. Math module is imported so that computations are become easy. Then I have taken input from the user so that user can decide the extension of Pascal's triangle. Before moving into the loops concept, first I will explain about the implementations of the for loops. So my first for loop in the code is to decide the number of steps of Pascal's triangle. Then second for is implemented for printing empty spaces to make sure that a triangle is printed. Then third for is for numbers in the Pascal's triangle, and these three for loops are adjusted in nested loops. So here my code begins with for I in range of n plus 1, so that in the Pascal's triangle the number or the extent entered by the user is also printed. Then we will move into first for loop. Here I have started my second loop where I have declared b as a variable which loops such a way that
It starts from n minus I and ends up to 0 with a step taking minus 1. So it is a decrement operator. Then I have initialized it such a way that empty spaces are printed in the same line. So after printing empty spaces, the control will enter into third for loop. My third for loop is to print the numbers in the Pascal's triangle. When the number exceeds 10, then number of digits in a number will increase and the symmetry of the triangle will be disturbed. So to maintain the symmetry, I have decreased the empty spaces in the same line for I greater than or equals to 10. That's why I am using two conditional statements. So let us check for one conditional statement. The algorithm is factorial of I divided by factorial of I minus j into factorial of j. So it is similar to the formula NCR equals to n factorial by n minus r factorial into r factorial. So the numbers are saved in S, and after saving, the number will be printed as a string, and after printing as a string, some empty spaces are given so that after again it will perform the loop and another number be printed in the same line. So up to this becomes false, the loop will be executed, and after the condition becoming false, it will come to the next statement called print. Here this print is used to move the control from same line to new line.
The code is executed and output is printed, thus program is finished.